So we are going to write the equation of a quadratic function with roots at 4 and -1 and 0, 8. Here's how you write those in point form. And here's how we are going to figure out the equation using a program called Desmos. So the first thing we're going to do is get the Desmos program. I can't spell it. And we want a beautiful free graphing calculator. So, are you at desmos.com? We are going to have Desmos assist us in finding the equation. And those points I'm going to put in Desmos as a table. So click on the plus sign and go to table. Plus sign and then table. And my points that I had written down were 4 and 0, -1 and 0, and 0 and 8. And you can see that they were put on the graph over here. Now, I click down in the next box, and we are going to ask Desmos to put this equation in standard form that's going to go through these points right here. So what's standard form? Y equals ax squared plus bx plus c. But do you see up here in the table, it says x1 and y1? And to tell the computer that I want it to use this table, I'm not going to just do y, I'm going to do y1. And to tell the computer that I want to use the computer to find the equation, I'm going to type on a special. So down here at the bottom, do you see the keyboard? Type on the keyboard ABC, and this symbol right here, kind of a little squiggly line, is approximately equal to, mathematically speaking. And then I don't need my keyboard anymore, so I'm going to make it go away. AX1 raised to the second power. I use the Shift 6 key on my keyboard to raise it to a second power. I believe you can also find a second power in these symbols down here. Plus BX1 plus C. Do you see right here? It tells you what the A and the B and the C are. Down here, what does it mean that A is a negative? Do you see the parabola going down? And you see the statistical part right here? If this is equal to 1, that means that over here, this matched up, those 3 points that I matched up made a perfect parabola. It's exactly equal to this equation. The computer automatically graphed it for me. I didn't do anything to graph it. And so if what the computer is doing is a statistical program called regression, and if the statistics equal 1, that means it matches perfectly. Let me show you the difference. Maybe this wasn't exactly. No, that still didn't. I'll figure that out in a minute. I'm still not getting something that's not making a perfect parabola. I'll have to get a different example. Okay, Let's try another example. Here I have 3 points. I want to find the parabola that goes through these 3 points. So I'm going to go to Desmos. I'm going to start again from the very beginning. I'm going to click on the table. -5 and 2 was my first point. -2 and 7 was my second point. 0 and -3 was my third point. Now, I'm going to make the computer figure out the standard form. Instead of put y equals, I'm going to put y1, keyboard ABC, approximately equal sign. AX squared plus B, oops, I left something out. This may be what happened to yours. Did it graph anything? Y. What kind of X is up here? X1 and X and 1. So you have to have the X1s in there. Ooh, those aren't pretty answers. These are not pretty answers, and they're not even exact answers. So I'm going to tell Desmos to change this decimal into a fraction. -1 point, a bunch of 3's, and it just did it. Why is it not doing it now? And then I am going to click on this little symbol right here, and it's still not doing. I missed something. I did. Yeah, okay. I needed more 3's. And so then it will change it into a fraction for you. What about this one? Let's see if I can get it negative. And so these would be a more accurate answer than using your repeating decimals. My next problem. Here we have 3 points. What would the parabola be that goes through these 3 points? Plus sign, table. My 3 points were 1 and 11, 2 and -5, 4 and -5. Y1, and then my special symbol here, MX1, oh wait, we're not doing linear, we're doing quadratic. I was about to type in y equals mx plus b. That's not what we're doing, is it? And again, you could change those decimal numbers to prettier looking fractions. Because the r squared is equal to 1, these points are perfectly matching my parabola. But what if we only have 2 points? Write the equation of a quadratic function with a double root at 4, 0. I mean, it's at 4, and so if the root is at 4, the point is at 4, 0. and the function of -1, 5. And so the other point is -1 and 5. Well, to make the statistics work, we've got to have 3 points. Where can I get my other point? Well, can you see that I put my line of symmetry in there? What does the line of symmetry mean? If there's a point on this side, isn't there another point on that side that's matching this one? So by using symmetry, I can get 3 points. I need at least 3 points for this regression to work. So you see how I found the third point. Using symmetry, I got my third point, and so now I'm going to go over here to Desmos, and my first point was -1, 5. My root was 4 and 0, and my other point was 9 and 5. Again, we have decimals. We can change those decimals. -1.6. So I had someone ask, is this easier to calculate it out by hand? Do you think those fractions would be very easy to figure out? Multiplying everything out by hand. So you can find the equation. Now, how would you write it down? That's y equals 1/5 x squared minus 8/5x. Nope. X doesn't go in the denominator, plus 3.2. And so that's how you would put the A, B, and C together in the standard form equation. And you can see that that matches up. Just FYI, if you want to change colors, you can click on that little gear and change to a different color if you want to. And so there's the parabola that goes through the 3 points. The only way you can learn to use a computer program like this is to practice a computer program like this.